Hello guys, welcome to the new video. Today we are going to discuss NFA without epsilon moves, NFA with epsilon moves. So let's start. What is NFA? Non-deterministic. Is a non-deterministic finite automata. Alright. So let's see what's in this. If there is input and if what is this? From every state, for every state, 0 or more transactions. Alright. Could be 0 or more transactions. Without epsilon move, that if there is a string and DFA, NFA accepts some language L, if W belongs to L, then at least one path that holds at final. At least one path. At least one path. That means it could be more than one path possible that holds at final. Right? So if W does not belong to L, there is no path holds at final. Alright? Either no path or every path holds at non-final. Alright? So there is no path holds at final. If W belongs to L, only one path, exactly one path in that case of exactly one path. So here the paths are more than one. Alright. So every DFA is NFA. Alright, but not NFA may or may not be DFA. Minimum DFA need not be minimum NFA. Alright. So what is this third property, that minimum DFA need not be minimum NFA. So NFA minimum NFA is less than or equal to minimum DFA. Alright. NFA. So how do we do that? That Q1 is epsilon state, that means initial states, and for A it could be Q1 at least one path holds at final, and A Q3 final, Q2 I mean. Q1 A Q1, B Q2, and Q1 Q2 and B, they does not expect B here. So number of paths, 1 invalid, 2 valid. For B is valid, 1 path. For epsilon, 1 path invalid. For A, 2 paths. For B, 1 path. For A, 2 paths, 2 valid paths. For AB is 1 path only. For BA, I think 0 path. For BB, 0 path. So it's 3 in any path. Is there any path? So for this, let's say this is a transition rule Q, Q, which is set of states, I mean set of states. Alright. So for 1 comma A, it can go 1 or 2. Alright, 1 or 2. This is 1 comma B. For B there is no path, so it could be 0 or more paths. Alright, in NFA possible. Okay, so yes, if Q is 1 to 3 and 2 power Q could be this, and number of and then power set of q is equal to 2 to the power n. Power set of q, set of all subset of q. What is the dfa nfa, comma a only one, no transition possible, one transition possible, two transition possible, and not so on. So let here. Now we will revise along with the what we say. We revise it along with the problem. Regular expression are to phi. This is a regular expression except phi, which means what is final state? For empty set, it should be minimum DFA is this, comma B. For NFA, what we said, there is no transaction, is only one transaction. There is more than one transaction. Alright. So number of minimum DFAs should 4 for one state. So alright, these are all minimum DFAs. Yeah. Note: in general, for every regular set, number of DFAs are infinite. Number of minimum DFAs is 1. Number of NFAs is infinite. Alright. Number of minimum NFAs is 1 or more. So minimum it could be 1 in case of DFA, and in case of 1 and more in case of NFA. Minimum, I think. Minimum. Right? Yeah. So how do we do that? Let's say L is equal to this epsilon asterisk over a comma b, regular expression. All right. So how do we do that? This is L is a language. This is over a comma b. Saying regular expression for this is equal to a plus b star. So how do we do that? And minimum DFA, we already done that. Comma b. This is a similar NFA also. There is no one stage for NFA. There is no difference minimum NFA and DFA. So what in the case of this is R a plus b plus what we can say a plus b a plus b asterisk. So how we do that? In the case of minimum DFA, that a comma b and a comma b. This is the case. Alright, in case of minimum DFA, two states are required. But in the case of NFA, what is the zero states? But we have to receive the a comma b case, no? So how to get that? F is a comma b, then a comma b. This is also the case. Yeah, we can do that also. We can do that also. And this is plus a plus b plus. Then what is this? Yeah, this is the different types of transaction for b from here. But this is also is still in NFA because you see all the except all the strings were generated by that thing. All right. What is a plus b star? A plus c star. What is this equivalent to a plus b, a b plus? All right. This is a b plus star plus b, a plus b star. This is also a plus b star. So L is equal to twisting epsilon. So minimum DFA should be this. All right. And if anything would happen, then it can be two states. So NFA, there is no dead state of case, so only one state. So what is this? Regular expression W starts with A. All right. So W here, W starting with A. So this is B step state. What that do in the case of NFA is if it accept there is no dead state from here. Yeah, is this no case of BF. Oh, that what we say. So let's see what is this. So this is regular expression ends with B, right? Ends with B. So how we do the DFA thing is A B. If it goes again A, but in case of what? And if this is A, if this is B, this is B, right? Yes, this is also the, or we also can there's more that I think, and again we can do that. B, B, B. Yeah, this is also the, but the final is this is final. This is final here. Minimum DFA, NFA. No NFA is there. So regular expression that contains A. So also for this, so but we can do that here, comma B, A, comma B. This is the very interesting case. Two states. What in this length of string should be 2. So what is this in the case of DFA? This is in the case of DFA is this. But in the case of NFA, what we will do is if it's A comma B, yeah, comma B goes to final. Again we will there's no transaction ahead. 3 states only. There is no transaction from here. If W is equal to 0, then k plus 2, k plus 1 states, all right. Regular expression is this. So what is it saying that epsilon is also possible, but AA, BB, at least 2, I think. What is this saying that? To do epsilon also A possible, all right. At least 2 length. So in the case of DFA, we start these things, right? So in the case of NFA, k plus 1 states, minimum k plus 2 states, 3 states. Oh, this is NFA here. Now again, what we are regular expression this, 2 length, this, 2 length, and whatever we are doing that, this would be possible, this could be possible, this could be possible. So we can, yeah, we are free to choose the loop here. 3 states are required. K plus 1, K plus 1. 4 states, 4 states. All things are similar. Note what does to note here. Length of W K, K plus 1. Less than K, K plus 2 is K plus 1. Greater than K plus 1 is also K plus 1. Number of W is equal to K, then K plus 2 states, here K plus 1 states. Where K plus 2 states, K plus 1 states. Number of A is W is like greater than is equal to K. So K symbol from begin is A. Our named F K plus 1. And here. Right. 10, yeah. Should be DFA. A, B asterisk, A and B. And no transaction for the date. Yeah. NFA without epsilon moves, NFA with epsilon moves. We're going to start here from. So NFA without epsilon moves and NFA with epsilon moves. NFA without that is this, not NFA without epsilon moves. So it will give NFA with epsilon moves. So first epsilon union epsilon. So it will goes to here. Transaction move is to transaction with no input symbol, transaction with zero input, transaction with epsilon. Yes, equivalent things. Alright. So what we do that? Here not a DFA, not it is NFA. So if one we can reach to 2 without any input, and if we are 3 we reach to 1 without any input. Yeah. 3 from comma A would be what? 5. If 5 here. So comma epsilon we can go to 1. Yeah, this is it. What is doubt 1. Second is A. Fourth is B. Right. Here are some doubts I think. We cleared. Now 000. Alright. So what is the previous question was that decimal of W is divisible by 8 ending with 000. What we see that 100, right? It should be divisible by 8. So 2 to the power 0, 2 to the power 1, 4, 3, 2 to the power 4, 2 to the power 5. So these are not divisible by this ending with 0. So what? How can we construct DFA? So 1, 2, 3. Right? This 0 here. So it gets 1 from here. It will go there. We get 1 from here. We again go there at 1. Right? This is the number of numbers should appear in last 3 bits. No one should appear. So the problem is what the initial state should be what? If 0 should also divisible by what? So what we do this here is if it is 0 not 1 0 0 1, if it is 0 and method 2 minimum DFA 4 states Q0 Q1 Q2 Q3 Q4 Q7. Alright, so to get 0 at Q0 here 1 here 0 here 1 0 2 0, we get 0 from here also, we go to here 4 4 4, so it gets 1 from here 3 Q1. So method 2 summary Is that right? If this is the case, why the reverse the initial state of? I think this is the correct one. One is here. Why does this go into that case? No offense. Thank you so much. But what was that?